Okay, we've discussed acids. We're now going to move on to a discussion of bases. A base is a substance that, when it's dissolved in water, increases the concentration of hydroxide ions. So we can look at a couple examples of bases. The first is sodium hydroxide. Dissolved sodium hydroxide, when it does dissolve, it completely dissociates into sodium ions and hydroxide ions. And of course, since you see the presence of the hydroxide ion formed as sodium hydroxide dissolves, that tells us it's a base. Similarly, if you look at the second example, that's ammonia. And when ammonia gas dissolves into water, it reacts with the water to form the ammonium ion and also hydroxide ions. So because it produces hydroxide ions, ammonia gas is a base. Now, just like you can have strong acids and weak acids, you can also have strong bases and weak bases. Now, a strong base is going to be a base, so it produces hydroxide, but it's also a strong electrolyte. So if you got a strong base that also completely dissociates into its constituent ions, then you've got a strong base. There are also weak bases. A weak base is a substance that dissolves in water to produce hydroxide ions, but it does so incompletely. So when ammonia dissolves in water, it does so in a manner that produces hydroxide ions. However, it does so in this reversible fashion. So in other words, the ammonia that dissolves, some of it remains intact as a molecule, but some of it reacts with the water to go on to form ammonium and hydroxide. And of course, these reactions occur in both directions simultaneously until a certain ratio is reached. But because ammonia does not completely dissociate into hydroxide, it's a weak electrolyte, and because it's a base, we call it a weak base. There are a list of strong bases and weak bases that you should have memorized. If you look at the list of strong bases, you will notice that any group 1 metal that's attached to a hydroxide, so lithium, sodium, potassium, etc., all of the alkali metals, so the alkali metal hydroxides, they are all strong bases. You'll also notice that the alkaline earth hydroxides, calcium hydroxide, strontium hydroxide, barium hydroxide, those are also strong bases. But there's a difference between these types of bases. You'll notice that the alkali metal hydroxides are soluble, whereas the alkaline earth hydroxides are mostly insoluble. And we'll explain that in a bit. But these you need to have memorized, and you should also recognize that ammonia, you should have that memorized as a weak base. Let's discuss this difference between the two different types of strong bases. If we look at lithium hydroxide, which is a strong base, we recognize it's also soluble, which means it completely dissolves in water. So that first equation, lithium hydroxide solid, goes to aqueous lithium ions and aqueous hydroxide ions. That's meant to represent that the lithium, the solid lithium hydroxide, completely dissolves, and every piece of it that dissolves completely dissociates. The complete dissociation makes it a strong base. The fact that pretty much all of the lithium hydroxide that you put in water dissolves makes it soluble. If you go down to the second example with magnesium hydroxide, in this case, we also have a strong base, but it's insoluble. So what does this mean? Well, if you look at the first equation below magnesium hydroxide, you see the solid going to aqueous. So imagine we have a big chunk of solid magnesium hydroxide that we're going to try to dissolve in water. Most of it won't dissolve. In fact, very little of it does, and that's what makes it insoluble. Now, a tiny amount does dissolve. So that first equation sort of represents the fact that a little bit of the solid magnesium hydroxide does dissolve. So that's the magnesium hydroxide solid, reversible arrow, going to magnesium hydroxide aqueous. The second equation, or actually the last equation on the slide, shows all of the magnesium hydroxide that dissolves completely dissociates into magnesium ions and hydroxide ions. So as I look at these two bottom equations, it is the first of these two with the reversible arrow that indicates that magnesium hydroxide is mostly insoluble. It doesn't dissolve very well at all. The second equation indicates that magnesium hydroxide is a strong base because every bit of it that dissolves dissociates into free magnesium ions and free hydroxide ions. Finally, we'll look at the case of ammonia, which is a weak base. And in order to understand how it's a weak base, we're going to have to imagine it reacting with water. So when ammonia reacts with water, a proton from water transfers from the water to the ammonia. When this happens, what we end up with is a proton on the ammonia, which forms the ammonium ion, NH4+. Because water has lost a proton, it goes to the hydroxide ion. So the fact that when ammonia dissolves in water, it reacts with it to form hydroxide makes ammonia a base. The fact that this happens in a reversible fashion, so that when ammonia dissolves in water, you do get some dissociation to hydroxide, but you also get a lot of intact ammonia that remains in the solution as well, indicated with a reversible arrow. This indicates that ammonia is a weak electrolyte and therefore a weak base.